Section 8 is all about function notation. So it's a little bit more terminology and learning how to use function notation more efficiently. So example A says y equals 2x plus 1. Okay, so that's a normal equation and what you're used to. But as you get moving forward in your mathematical careers, you're going to start to use things in function notation. So the first type is called Euler notation. And what you do is you just cross off the y and you're going to change it. Okay, and it says to name the function b. So I'm going to say b of, and this variable that it already had there is x. So b of x equals, and then you rewrite 2x plus 1. So the whole point of today is to get rid of the y on the left side of the equation and write that part in Euler notation, okay? And the name comes first. So this part here is your name. So if you were going to kind of write a note, it'd be name in parentheses, your variable equals, and then your normal equation. Okay, so whatever is on the right side never changes. It's only what is on the left side that changes. So the name comes first, b, and then in parentheses goes the variable that you were given, x, okay, and then you just rewrite your equation. Now why? Okay, because it's Euler notation, it's what they use in advanced math. Okay, what is the dependent variable? Well, dependent is usually your y, so what do you have in place of your y? The b of x. Okay, so the dependent variable is b of x. Most questions say something like find b of negative 1. Okay, well what this means is if I had b of x, okay, this is I just plug it in for x, okay? Whatever's in that parentheses, you plug in for x. So I'm going to say 2 times negative 1 plus 1, because my formula was 2x plus 1. So 2 times negative 1 is negative 2, plus 1 is negative 1. So b of negative 1 equals negative 1. Okay, so b of negative 1, just plug it in and evaluate it. So that is example A with Euler notation. Example B is mapping notation, which is similar. So this time you get the name, but now you have a semicolon, and then the variable, and then an arrow, and then your equation on the right side. So you get your name, a colon, the variable, and then the arrow. So mapping arrows. Okay, hopefully that helps you remember which one is which. So again, you're just changing this left side. You cross off the y. It says our name is C. So I have C colon. My variable here is n and then arrow. Okay, so C, your name, colon, your variable n, and then arrow, and then you don't change the right side. So 3n squared minus 5. The independent variable, which is usually your x, well here instead of an x, we have an n. Number 3 here says find c of negative 2. Okay, so this is usually where your variable is. So that means plug in negative 2 for x, or for n in this example. So I'm going to say 3 times negative 2 squared minus 5. Remember your rules of operations, so I should square that first. So that's 3 times 4 minus 5. Multiply first, 12 minus 5. So that gives me 7. Okay, so rewriting it in mapping notation. Again, all you're doing is changing the left side and leaving the right side alone. So if I say example C, consider that. Write the function in Euler. So now all you have to remember is which one was Euler. The one with the parentheses, the one with the arrow. Well, arrows goes with maps, so Euler gets my parentheses. So you delete your y on the left side. The name is g, so the g goes first. In parentheses, my variable is b equals b to the third minus b minus 7. And that's done. Part 2 says find g of negative 1. So plug this in for x. So I've got negative 1 to the third minus negative 1 minus 7. Negative 1 to the third is negative 1. Minus a negative becomes a plus 1 minus 7. So my final answer is negative 7. Okay, so when it gives you something like this with a number on the inside, just plug that into x or b or n, whatever your variable is. And letter D, example D, the cost of making a phone call from an airplane is $3.50 plus $2 for each additional minute. Write an equation in Euler notation. Okay, so let's write it as if we were going to write it in slope-intercept form. So my slope would be the 2 for each additional minute. So I'll go to x plus the $3.50 that originally cost. Okay, so you guys are really good at that. You've done that before. So the each or the every is your slope, so 2x plus the 350 that it costs, okay? It didn't tell us what we want to name it, so maybe I'll write P for the phone calls, and then we chose X already, so of X equals, okay? Again, you could have picked anything there because it did not tell you what the name had to be. So to rewrite in that in mapping, well, we already picked P for our name, so P, mapping is the arrow, so then I have colon, and then my X, and then my arrow, and then my 2X plus 350. Okay, so anytime you're rewriting things, all you're doing is changing the left side. The right side stays the same no matter what. And find the cost of a 7-minute call. Okay, so 7 minutes, plug it in for X. So 2 times 7 plus 3.5 means that's going to cost me $17.50. Okay. And then one different kind is also just kind of looking at a graph and saying, okay, can you look at this and then figure it out? So this says find f of -2. Okay, well, we kind of figured all of these, okay, the f, or we're changing the y. So this is like saying, when does y equal -2? So here's -2 on the y, and here's my x coordinate. So my x coordinate was 2 at that point. So x equals 2, because we had the point, 2, 1, 2. Oh, maybe that's closer to 1. So that's closer to a -1, because this ordered pair is -1. You probably can't see that. -1, -2. So I wanted to know when y was 2. Well, that's when x equals -1. So you're just kind of reading a graph backwards. Okay, and that's all there is to Euler and mapping notation. So see you tomorrow.